Hello everyone, welcome to my channel, Physics in a One Word. Today we start new topics, motion in one dimension. Before we start, we should answer what is the displacement and distance. It is important to understand the difference between distance traveled and displacement. They explain consider the road marked in the figure. Displacement is the distance moved in a particular direction. The unit of displacement is the meter. Displacement, d. Displacement is a vector quantity. On the figure, displacement is the length of the straight line from A to B. A distance, for example, is 5 meters. 5 meters. So, distance is how far you have traveled from A to B. The unit distance is also the meter. In this example, the distance traveled in the length of the path taken, which is about, for example, 10 meters. Sometimes the difference leads to a surprising result. For example, if you run all the way around the running track, you will have traveled a distance, for example, 40 meters. A position. 40 meters. But your displacement will be 0 meters. Because displacement is 0. You start from A point and finishing for N point. And distance is 0. So, in everyday life, it is often more important to know the distance traveled. For example, if you are going to travel from Paris to London, you will want to know what's the distance you should travel. For example, it's 40 kilometers. So if you want to travel by plane, you should need the what distance from Paris to London. You should like this one. You should travel by car from this line. You travel by plane from this line, straight line. So we will talk about velocity and speed. Velocity and speed. So, both speed and velocity are measured of how fast a body moving, but velocity is a vector quantum and speed is a scalar. Velocity is defined as the displacement per unit time. Velocity, displacement for unit time. Measured meter per second. Speed is defined as a distance traveled per unit time. Distance time measured also meter per second. In other words, velocity is a vector quantity, displacement, this one, displacement per time. Speed, it's a scalar quantity, distance, L per time, speed, L per time. Speed is a scalar quantity. So, how we measured displacement? Displacement measured delta x vector scalar x2 minus x1. So, where is the x2 is the position vector at time 2 t2, and x1 is the position vector at time t1. x2 and x1 is the last position and initial position. Change of positions, it's called displacement. This one is called delta. This means it's change in. So let's go draw the position graph times. Position graph times. Time measured per second and position measured per meter. So this one position and position time graphs. So the important graphical interpretation helps us to derive the constant velocity of the car from of the car. So if you draw this line, so this point is x1, x0, this point is x1, it's a time, equals to 3, it's a 2, it's a 4, 2, 0. So x0 is, for example, is 2 meters, x1 is, for example, is 4 meters. Okay, velocity is the slope of the line in the position time graphs. It's the slope, like this one, or maybe like this one. It doesn't matter. We will use the green line, okay? We use green line. And velocity, slope, it's a eta, we call eta, it's a delta x divided by delta t. Delta x, it's a x final minus x initial divided by t final minus t initial. It's a v. For our graph, its velocity equal to 4 minus 2 divided by 4 minus by 0. It's a half meter per seconds. It's a constant velocity formula. If you look at this one, we get that formula. X final, X initial equal to V multiplied by T. It's a X final, X initial plus V divided by multiplied by T. It's called position time position time equation. Position time equation for uniform motion. For uniform motion. So, for example, this is the position as function of time. It's x2, x0 is it's a x initial, v multiply b. For example, using CI units, x2 equal to 15 plus 40 t, it means that the initial position of the object is 50 meters. Initial position is 50 meters, and it moves at a constant velocity 40 metaseconds in the positive direction, because this one is a plus. Similarly, if you have this equation 5 minus 2t, that means that x0 equal to 5 meters and initial position 5 meters, and body moving in negative direction as velocity 2, because this one is 0. So, my friends, see you later, and next time we talk about average velocity.